Hello there, and a very big welcome to Road to Space. We're coming to you live from the European spaceport in French Guiana for a very special mission. It's the first launch for the Amazon LEO constellation on board Europe's Ariane 6 rocket. Amazon LEO's mission to deliver reliable internet beyond the reach of existing networks, and Arianespace's mission to deliver the next 32 Amazon LEO satellites to space. And to do that, we're using the most powerful version of Europe's rocket. For the first time ever, we're launching the Ariane 6 version with 4 boosters. Over in mission control, about 16 kilometers from the pad, the team's inside what we call the fishbowl there, that protective glass, the operational teams focusing hard as we get closer to launch. Now, we're actually in our commentary box looking down over that fishbowl. We've got a great view from up here. I am joined by 2 fantastic commentators from Arianespace. That's the company who organizes the launches. Samuel Rogez is our rocket expert for today. Great to have you with us, Samuel.
Hi, Katie. Great to be here to commentate this launch live together with you.
And in the commentary box next to us, we have got Aaron Lewis, also from Arianespace. He's going to tell us about the mission and Arianespace's partnership with Amazon LEO. Thanks for being with us, Aaron.
It's great to be here, and the water is fine in the fishbowl.
I'm glad to hear it. Samuel, so yeah, it's a really exciting launch today, isn't it?
Yes, indeed, because it's the first one we see this version with 4 boosters, so it's the most powerful version of Ariane 6. It should be a really impressive launch. We are all really looking forward to see that liftoff, so really a lot of excitement here.
And looking good for launch?
So far, so good. Yeah, everything is going normally. Everything's green, so all good.
That's what we like to see, green boards. Aaron, we have a number of launch parties going on around the world.
Yeah, our friends at Amazon are having a signal event in Paris, and this fine broadcast is being live streamed into over 200 offices in 20 different companies for Amazon across the world.
So a big shout out to everybody watching all over the world. We have an exciting journey ahead. Aaron, Samuel and I will be with you all the way. We're going to be finding out about operations across the range. Of course, we'll be seeing a lot of this launch pad before launch, the dedicated Ariane 6 launch zone, which includes the pad and also the launcher assembly and integration buildings.
We'll also go into the launch control center. So we'll see also the teams in charge in this launch control center closer to the pad, and they are responsible for managing all the operations on the rocket and the pad before liftoff. Here they are.
These are the Launch Control Center teams. We have another control center. It's called the CVI. We call it in French, or the Quick Look Telemetry Team. There they are. They will be taking on monitoring the rocket after launch. But back here in mission control, let's go into the fishbowl now to find out how the launch is progressing, how things are progressing for today's launch. Over to David Cavalloles. David is the CEO of Arianespace. David, thanks ever so much for coming to chat with us. How are things looking for today's launch?
Hi, Katie. Well, Ariane 6 is now standing on its launch pad, and for the very first time, it's equipped with 4 boosters. That's why we call it Ariane 64. This is Europe's heaviest launcher. So at the moment, all the parameters are green. The systems are working nominally. The weather is absolutely perfect. So we are ready for liftoff in now around 40 minutes.
Good to hear. Tell us a little bit more about our passengers, David, our Amazon LEO satellites.
Absolutely. Today is a very special mission to us because this is the first one for our client Amazon, the first of a series of 18 launches to come. This is an absolutely strategic partnership to us. And as you mentioned, today on board, Ariane 6 is carrying 32 satellites. This is the first time we carry as many satellites in Ariane 6. And with this launch and the upcoming ones will contribute to deploy the Amazon LEO constellation. It will be an absolutely unique constellation, bringing high-speed internet with a reliable connection all around the world.
Yeah, super important. But why is this launch so important? I mean, this will be the 6th launch for Ariane 6.
Yeah, you know, we are engaged in a very fast ramp-up with Ariane 6, and with this launch, we are again accelerating, and we'll continue doing so. The other very important aspect is that last year we performed 4 launches for institutional customers. today, this is our very first Ariane 6 launch for a commercial customer for Amazon. And I know that today, thousands of Amazon employees all around the globe are watching this event, and it means a lot to us. So thank you very much.
Absolutely. Thank you so much, David. You can head back now to take up your position on the flight desk, and best wishes to you and all the teams for the launch. So we were hearing there that Ariane 6 comes in two versions, the 62 and 64 versions, depending on the number of boosters. The rocket's made of several stages, sections, Samuel. We call them stages.
Yes, indeed. So first you can see here on your screen the rocket itself, complete rocket. Its height is 62 meters tall, so it's quite tall. And the total mass liftoff will be 870 tons, so massive. Part of this rocket is the main stage. As you'll see, it's made of two tanks mainly, one of hydrogen, one of oxygen. And of course, these are used to propel the Vulcan engine, which is below this main stage, attached to its engine thrust frame. Engine thrust frame, then hydrogen tank, oxygen tank, and then on top of it, a skirt, which is attaching this main stage to what's coming on top. And of course, it's the upper stage. This is the one key element as well of Ariane 6 with the Vinci engine and two tanks, hydrogen and oxygen again. The stars of today are, of course, the four boosters that you can see here that are coming around the main stage attached to it. They are 22 meter tall, so it's quite tall. They are the equivalent of an 8-story building and diameter of 3.4 meter. You can see inside this booster, they are filled with solid propellant loaded with 142 tons of propellant each booster. Of course, the main part of Ariane 6 today is our passengers, the Amazon LEO satellites. They are on top of it, integrated onto a mast which we call dispenser and covered by the long fairing. So this is the first time we fly this long fairing, 20 meter tall, so well covering our passengers for today on top of our rocket.
Indeed, the first time we fly the long fairing is a flight of premieres today, or premieres, as you might say, Aaron. It's the first time as well that Ariane 6 is launching satellites for Amazon LEO.
Yeah, that's right. A lot of firsts. And Amazon LEO is Amazon's low Earth orbit satellite network. Another first is that we are launching a constellation for the first time. And another thing to note is that this will be the first new heavy lift variant to address Amazon LEO satellites. But Amazon, it's worth pointing out that is calling this flight LE-01, which stands for LEO Europe #1. And that mission name is a nice nod to Arianespace, which is the only European launch provider in Amazon's lineup of rockets.
Indeed, and they are scheduled to lift off in around 35 minutes' time. What's going to happen after that?
Yes, indeed. So we'll have the liftoff towards heading northeast direction, as you can see here, the ground path on the map. It will be powered by the five engines, and amongst them we find the 4 boosters. They will be separated after 2 minutes and 25 seconds, as you see, and then 50 seconds later we'll have the fairing separation once the launcher has left the atmosphere. After 7 minutes and 37 seconds, then the main stage will be shut down and will be separated. A few seconds later, we'll have the upper stage Vinci engine ignition. This will be the first of 3 boosts. It will burn for 11 minutes. And then we'll have switched off the engine. We'll have a coasting phase for 52 minutes going up over Europe and over India. And then in visibility of Awaroa station, we'll perform a second boost of the upper stage. Then we'll be ready to start the separation sequence for our passengers, separating satellite 3 by 3, then 2 by 2, and finally, last one. This will last approximately 25 minutes. And the next step of the mission after that will be another coasting phase to lead us south of Australia, where we'll have the final boost of our upper stage Vinci engine. This will be followed by staged passivation, and all of this will lead to re-entry of the upper stage above Pacific Ocean. This is really key to avoid leaving any debris of the rocket orbiting the Earth.
Which is, of course, super important. Now, as Amazon LEO's first launch with their European partners, this is actually really an important moment, isn't it, Aaron?
Well, it's more than just satellites reaching orbit. It's about European innovation and industrial capability. Amazon's the biggest commercial customer for us at Arianespace. We've got 18 launches planned over the next few years. And that record-breaking contract isn't just big for Arianespace. It's had a huge impact throughout the European supply chain, creating demand for everything from rocket booster production in Italy to dispenser systems designed and built in Sweden. And all told, these contracts support thousands of suppliers and highly skilled jobs across the continent, and have added more than $2.8 billion to Europe's GDP. So from the launch pad in French Guiana to factories across Europe, this mission connects everybody. It's a win for European industry, European workers, and for the customers and communities around the world who really, really need this connectivity.
It really is. I mean, I think it's fair to say that it's a truly historic launch, so it's a big day for everybody. And of course, the internet, I mean, it's just so important to us all, isn't it, these days?
Yeah, absolutely.
It really is. And constellations like Amazon Leo are quite literally transformational. I never tire of seeing rockets firing into space. Now, the name Amazon Leo is a nod, of course, to the constellation's location in space, LEO, low Earth orbit. Right, Aaron?
No, it wasn't always called that when we first started having our conversations with Amazon. Its internal code name was Project Kuiper, which I thought was pretty awesome, but Amazon Leo is even better.
Oh, yeah, I agree. I think they're both fantastic names, actually. And there's so much that goes into building something on the scale of Amazon Leo, from the satellites themselves to the antennas that you use to connect to the network, to all the ground infrastructure, the networking that bring it together, and the journey to today's launch. Well, it's been quite a ride, to be honest. There's here on Amazon Leo, let's meet some of the people now who've been helping to build the system.
It all starts with a countdown. But a countdown to what exactly? 6 years ago, we took on a journey to build the most advanced and the most modern communication system in the world. There are almost 3 billion people that don't have high-speed connectivity. Imagine if they had the ability to be connected just like you and I do, what they could do, what contributions they could make.
This mission is ambitious for a truly worthy cause. It's going to impact communities that cannot be reached with fiber traditional communications. The solution really has to be from space.
You can think of Project Kuiper as a three-part system: the satellite constellation, the customer terminal, and just as critically, the ground network and software that ultimately deliver connectivity. We have set out to design the most advanced satellite network ever built, and we have created the whole thing in-house at Amazon. You need just about every technology area to contribute to build the satellite: the propulsion system, the solar arrays, the silicon, the phased array antennas, the optical inter-satellite links.
The team has to be innovative, agile, resilient, as we're moving very, very fast. Building, testing, developing in-house has been an extraordinary ingredient.
When we first proposed Project Kuiper internally, one of the first questions was, can you produce an affordable customer terminal? We knew that was going to be the linchpin of our system.
The big breakthrough for us was combining transmit and receive antennas into a single aperture. No one had ever done this in the Ka-band. That let us pack a ton of performance into a really compact, really low-cost design. We're going to build tens of millions of these antennas, and we are well on our way. The design is done. We're now in the factory manufacturing it.
We talk about the satellites in constellation, but Kuiper is a satellite constellation being operated as a network across hundreds of ground gateway terminals.
Our ground network is spread out all over the world, and each site connects back to AWS. We already have a bunch of these sites installed everywhere from Australia to Germany, and more of them are coming online every month.
There's a big difference between launching 2 satellites and launching 3,000 satellites.
The past couple of years, my team has really been focused on how to achieve scale. Our own dedicated payload processing facility gives us the ability to control our own destiny. We've got the capacity to integrate up to 5 satellites per day and launch 3 simultaneous campaigns. Heavy lift rockets have higher performance, so we can take more satellites to orbit on any given launch. All of our heavy lift launch partners have had a successful first flight, so that's been a pretty exciting thing for us to see because we made those investments years in advance.
All of the pieces have come together to support that first launch, and the next one, and the one after that. It might not all go perfectly, but we have an incredible commitment to this project and an incredible team committed to its mission. All roads lead here, a countdown to launch. And with more than 80 missions planned, we're just getting started.
Well, that was an incredible primer on the motivations, the methods, and the history behind the development of the Amazon LEO constellation. It's really incredible. And one thing that we're really fortunate to have is you here, Lisa Scalpone, today to talk about the system, the program. You're the director for worldwide consumer at Amazon LEO, so you're heavily involved. I've got a few questions for you that might help better inform a lot of our watchers about the Amazon LEO constellation and what its capabilities are.
Yeah, Aaron, thank you so much for having me here. We are so thrilled to be in beautiful French Guiana. This is our first heavy lift launch and the first of 18. So the Ariane team will have to get very used to seeing the Amazon team down here.
I think we're going to be very happy to get used to all of that in due time. Well, let's dive into the questions that I've got for you here today. What's Amazon LEO and why are you guys doing this? Just a basic question for you.
Yeah, so it's classic Amazon. We started with a customer problem, which is billions lack connectivity to the internet. And we saw that we had the infrastructure, the people, the resources to solve that problem through a low Earth orbit constellation. So this is our satellite constellation. Our first generation will be over 3,000 satellites at 590 to 630 kilometers in altitude.
Wow, that's incredible. That's very admirable. LEO for high throughput it's a really new thing. Yeah. What's it mean for customers and users?
So LEO is different than traditional satellite networks that were at geostationary orbit. So LEO being so low, it takes away the latency. It's very low latency. In other words, there's a very small amount of delay. This means real-time communications like video conferencing work great. It feels like terrestrial broadband. You can do other real-time applications. So it's really the key to unlocking a fantastic internet experience.
So let's get down to the experience. How does Amazon make it different? Well, let me back up. What's different about Amazon? I mean, what sets you guys apart?
Well, first of all, Amazon is a name that millions of consumers, households, businesses already know, already trust, and understand that we are hyper-focused on delivering on the customer and delivering a fantastic customer experience, great value for your money, and innovation, expertise. And just to point out one of my favorite parts of it, first of all, we're Amazon, we're going to be focused on value and making sure customers love the value they're getting, the performance. And second of all, the innovation is built in throughout the entire network, the entire system. You saw a little bit on the video before this. My personal favorite is our customer terminals, the innovations there.
Well, we have Exhibit A and B, and then also Exhibit C down on the floor of the fishbowl of these customer terminals. Why don't you walk us through how people will use them, what they're used for, where you'll find them?
All right. So this is kind of our workhorse terminal. This one is, you can see how small it is, but this is the home broadband terminal. It goes up to 400, supports up to 400 megabit speeds. Easy to install. You can be on a tripod, can be mounted on your house easily, and this will give you terrestrial grade broadband, and for businesses or for households.
Wow, that's amazing. And you want to talk about the larger one that we have down on the floor there?
Yeah, so I don't know if folks can see that one. Maybe they can get a shot of it. It's actually not that much bigger, but it is enterprise grade. Full duplex, goes up to a gigabit in download speeds, 400 megabit upload speeds. So it's fantastic for applications like backhaul, supporting larger enterprises, whole communities. We think it's just fantastic performance. It's going to delight our customers.
Yeah, it seems like a real game changer. Well, we have about 20 seconds if you want to just wrap it up and talk about what you think the global impact is going to be for Amazon LEO's introduction.
We absolutely hope to make global impact. Providing connectivity throughout the world has the possibilities to change communities, businesses, and people's lives. So it's a hard challenge, but we're up for it.
You guys seem like you are. Thank you so much for being here, Lisa.
Thanks, Aaron. It's great to be on the show.
Indeed, thank you so much, Lisa, for telling us, talking us through those terminals. That was really interesting. And, I agree with you. The impact of connectivity now on people's lives is really literally transformational. So just a quick reminder that we are 20 and a half minutes to the launch of our Amazon LEO satellites. Lots of people have burning questions about space and rocket science, which can be quite a confusing issue sometimes. And I think that Aaron may well be joined now by a very well-known French influencer, Jean-Baptiste Nicolet, from the I Collection. I'm hoping that the guys have been able to play musical chairs in Aaron's commentary box.
No, I'm still in the same place. Jean-Baptiste has replaced Lisa, but really, really honored to introduce Jean-Baptiste of the I Collection. He is a tech influencer with a massive following in this social media, and he's here to learn a little bit more about the space industry. Typically, you're involved in tech, but today you're here to learn about space. So the questions aren't for you, they're for me, right?
Yeah, that's it, yeah.
Well, we can get right down to business. If you want to dive in and throw some of your toughest questions or your craziest questions at me, I'm here to take them.
Great. First of all, thank you for having me today. It's my pleasure to be here.
You're absolutely welcome.
So let's start with a quickfire round. I'm going to throw some space words at you. Explain each one in one sentence. You are talking to a 10 years old. You are
Fantastic.
ready?
Yes, and I have an 11-year-old son, so this is perfect.
Great. So, what is a one rocket myth you want to kill off once and for all?
The one rocket myth that I want to kill. Okay, so as the launch vehicle is ignited for liftoff, you're going to see water pouring into the flame trench. You're going to see these big jets of water spraying towards the nozzle where the fire is coming out of. Now, there's a misunderstanding often that the water's there to cool the jets, to calm the flame. That's not what that's for. The water is there to prevent bad vibrations from destroying the launch vehicle and the payloads that are there beneath the fairing. So, shockingly, that water prevents shock. It kind of blankets the vibrations coming up. And when a launch vehicle is ignited, it's like 1,000 Metallica concerts going off at once. You got to stop that noise from shaking the rocket too violently. So that's what the water's there for. Myth killed, I hope.
You know what? I didn't know that, so thank you.
Yeah, anytime.
Second one, what's the telemetry?
Telemetry. Okay, I see you have a smartwatch on. That's like the smartwatch on the launch vehicle. It tells us where it is, where it's going, how fast it's going, and how the systems on the launch vehicle are performing. It provides all sorts of data to us. So its telemetry is the smartwatch on that launch vehicle.
Okay, and what is the cryogenic?
Cryogenic. Cold. It's very cold. So the fuels that we load onto the launch vehicle, you have liquid oxygen and liquid hydrogen. We've reduced them to temperatures lower than 200 degrees below 0 Celsius. And those super chilled propellants allows for massive thrust coming out when it's ignited, when it comes out of the nozzle. So cryogenically cooled propellants are very cold. So in a word, cryogenic is super cold.
Okay, do we have the time for one last question maybe?
One or two, yeah, go for it.
Okay, so maybe last question. What do you think about a rocket launch that will surprise people the most?
The one thing that would surprise the most about a rocket launch, okay, you look at it, you see a lot of hardware, you see metal, you see the gantry. Most of a rocket launch, 90% of a rocket is fuel. So the cryogenically cooled liquids, the liquid oxygen and the liquid hydrogen, and then the solid boosters. That is most of the rocket. The rest of it, the metal pieces, those are mostly, below 8 or 9% of the rocket's mass. It's incredible.
Okay.
So, anyhow, it's it's those liquids and those propellants to some degree that pressurize the launch vehicle. It's like a can of soda when it's full. You know how rigid it is. So, those liquids, they solidify that rocket. So the skin of the rocket's only a couple of millimeters thick, but with that tension, it's very rigid and can withstand the pressures of flying into space. So I hope that is an interesting fact point for all the people that you're influencing through your influencer influence.
Yeah, everything is clear now. So thank you so much, Aaron.
Yes, good to see you, Jean-Baptiste. We hope to have you back. Yes, thank you so much. Cheers.
Thank you so much, guys. And I'm glad to know that we've got 1,000 Metallica concerts of sound waiting on the pad to lift off and be dampened by the water. So let's just come back now to our launch, 15 minutes there, our rocket on the pad, standing tall, waiting to lift off. Let's hear from Panos Panay, who's the Senior Vice President of Devices and Services at Amazon, who unfortunately couldn't make it for the launch today.
Hey everyone, this is Panos Panay from Devices and Service here at Amazon. I'm lucky enough to lead the team that drives a lot of the work, and what an amazing team it is. But I have to tell you, I wish I was there with you right now at this launch for LE-01, with Ariane 6. Like, what an opportunity to change the world that we're leading together. The teams coming together to ship this payload, our largest payload yet, is quite amazing. We are getting that close to delivering this constellation to change the world, to remove the digital divide amongst people who cannot be connected or companies that just need incredible, incredible connectivity. And it all starts with the amazing work that you all are doing. I wish I could be there with you. I wish I could be there for the launch. Although I can't be there, I am there in spirit, and I wish you all the very best of luck and an amazing launch. Thank you so much to everyone at Arianespace. We truly are grateful here at Amazon.
Now, Samuel, we mentioned earlier, David, we heard him mention earlier how Ariane 6 has been designed very much to respond to a sharp ramp up in production.
Yes, indeed. It has actually completed 5 flights in less than 18 months. So this is really the fastest production ramp-up ever achieved when we talk about heavy launchers. And of course, the team at Ariane Group and all the industrial partners are full speed to accelerate the production even more and double the pace in 2026 as compared to 2025.
Pretty busy times at the spaceport. Why don't you talk us through the preparations for today's launch?
Yeah, of course. So all started with the arrival of the special ship called Canopy at the port in French Guiana here on 2nd of January, carrying the sections of Ariane 6 from mainland Europe. They were then transported by road to the spaceport, unpacked, and then we proceed to the horizontal assembly of the main and upper stage in the launcher assembly building, as you can see. Once assembled, we've proceeded with the transfer of the core stage to the launch zone. It's 800 meters away with an automated guidance vehicle on the 22nd of January. Then this central core was lifted up and placed below the mobile gantry, which is this gigantic building protecting the launcher while being prepared. The boosters joined the central core. We integrated them around the main stage, 3 boosters the same day and the 4th the day after. You can see the team down there and how tall the boosters and Ariane 6 are compared to the team. For what concerned our passengers, Amazon LEO satellite arrived in French Guiana on 18th and 20th of November last year. They were prepared and integrated onto their dispenser. Then the complete stack was then encapsulated below the Ariane 6 fairing. This forms what we call and what we see the upper composite, which was then placed on the transportation trailer. Last Monday it was transferred to the launch pad. And then it was lifted and integrated on top of the launcher, on top of the upper stage, as you can see on these nice pictures. And over the last days, we had, of course, safety operations, arming of the pyro systems, and today we started the final countdown with the mobile gantry removal, in particular 9 hours ago.
Got our final weather check coming up at T-10. That's 10 minutes to launch. What are the conditions that we need to keep an eye on?
So we are checking mainly 2 parameters, 2 main parameters. First one is the wind. We are checking both the intensity and the direction of it between mainly 10 and 20 kilometers. It's mainly for safety reasons in case of launcher malfunction. And the second one is the lightning risks on ground mainly. It's safe because we have these giant masts that protects the launcher, but during ascent we don't want the lightning to damage the avionic equipments, for instance, of the launcher. Here you can see the weather station where the team are performing the prediction and the weather forecasts. For this they are using special balloons carrying instruments that send back information on atmospheric temperature, pressure, or humidity, for instance.
And the weather status panel is green, so that's good news. We are go for launch in the weather department. And the European spaceport is on the Amazonian coast of South America. In French Guiana, it can be pretty hot and humid around these parts, can't it, Aaron? What's the weather like today?
30 degrees Celsius, exactly what you'd expect on the Amazonian coast of French Guiana, which means, yes, Amazon is literally launching satellites from the Amazon. Gotta love that coincidence.
Nice. And look, we've got clear skies, but even 10 minutes ago it was actually raining, but the clouds have parted, so fingers crossed for a beautiful launch. Can see the water tower on the right-hand side of the screen there. You were telling us earlier, Aaron, about how the water floods the pad. Well, that's where it comes from. Back in mission control, everyone's got their eyes on those status panels that we can see there on the left-hand side. We like those to be green, Samuel.
That's true. It's a bit the traffic light of the launch control center here. They are gathering the health, the readiness of the three main systems across the base that needs to be ready for having the launch happening. So first is the launcher and its ground systems. It's called Ensemble de Lancement and Lanceur. Then second group is the range, which gathers telemetry, radars, the weather, of course, and safety, both on ground and in flight. And last one, of course, is our passengers, Amazon LEO satellite.
Which are quite nicely, neatly tucked up inside the top of our rocket in first class with their seatbelts on, Aaron. What do they look like in there?
This is exactly why we're here. These satellites are the heart of the mission that you can see in the illustration. You can see their solar arrays are all neatly folded as they're there, latching on to the payload dispenser. It'll actually in flight happen in reverse order than that. But these satellites include a ton of advanced technology on board. They include the key systems and subsystems that allow them to operate safely and reliably in space. And what's remarkable is that all the technology that you see on these satellites and the technology that you don't see, they're designed and built in-house by the Amazon LEO team, as you witnessed in that film earlier. Remarkable stuff here. And the satellites are going to remain attached to the dispenser until they're all sequentially dispersed and released into space. And the timing of this has got to be precise and the delivery accurate. The dispenser's role is critical for the important job it carries out. And then at the bottom, you can see the new launch vehicle adapter, that V-shaped end of the dispenser, bearing a special burden connecting the dispenser to the launch vehicle.
And seeing those 32 satellites enclosed under the fairing like that, stacked on the vehicle, it really brings home the scale of the mission, doesn't it? Gosh. So here we are, 6 minutes and 24 seconds now to launch, looking across, I believe, from the Vega pad there, which is one of the other rockets that launches from the spaceport, and a nice shot there of what we call the Carno, which is the exhaust pipes, if you like.
Yeah, it helps.
The concrete structure.
Indeed, quite a giant one, which helps pushing away the exhaust gases away to avoid them from being accumulated down the pad.
You'll see that at launch. There's one on each side. Yeah. And you'll see those fumes and gases coming out of those. You can only see 2 boosters there, but we have actually got 4 boosters on board today.
We confirm.
We can confirm, and we've got 2 yellow things at the top. Those are the cryogenic arms clamping onto the top of the rocket, feeding. There's a close-up of them there, feeding the very cold propellants into the upper stage, which Aaron was telling us about earlier. Right, back here in Mission Control, the Range Operations Manager is now getting ready to announce the beginning of the next big moment, which will be the Synchronized sequence. It's Jean-Frédéric Alassa today.
À tous de DTO, attention pour la séquence finale lanceur. Top, H0-5 minutes.
We have the beginning now of the synchronized sequence. It's been initiated, or the automatic sequence, as we also call it. It's the last 5 minutes now in the final countdown, and our rocket's becoming progressively autonomous. There's an awful lot of very, very precise operations happening, aren't there?
Yeah, it's quite a dense step here. We have many operations being run, very precisely timed. combining checks, pressurization of the tanks, activation of different systems and valves. And in fact, the control of the operations is gradually being handed over from the ground to the launcher onboard computer. It will be at the end the onboard computer of Ariane 6, which will send the main engine ignition command and the booster ignition commands. And today, it's worth to mention, we have a 29 minutes launch window.
That's good to know. That gives us time to reschedule the launch, if necessary, within that 29 minutes. Now, the launch pad is just one of many facilities here at the base. We call the whole thing the range. That includes the tracking stations along the flight path. And I guess, Aaron, in a way, you could sort of compare it to an airport?
Yeah, that is an apt analogy, comparing it to an airport or air traffic control. Mission control, like an air traffic controller, they can give the final authority for takeoff or for grounding. So, yeah, absolutely. They maintain tight control over the authorizations given to the launch vehicle to take off when the conditions are absolutely right.
And we have another control room here at the base, launch control. It's much closer to the pad. I guess you could think of it as the cockpit of the plane.
Yes, indeed. Quite a busy cockpit, as you can see, given the size of the teams there. And they are inside a concrete bunker 5 kilometers away from the launch pad. These are the closest team to the launch pad. And they are the operational teams sending various commands to turn the launcher avionics on, to fill the propellant tanks, for instance, to pressurize the tanks, and to run all the planned tests step by step to confirm that the launcher is getting ready for launch. And we have behind them, behind a glass window, another team, the engineering team, who are monitoring all the operation closely. Here you can see them, making sure that all is happening as expected. They are checking many parameters, such as temperatures, pressures, electrical currents, both, of course, on the launcher rocket side, but also on the ground.
Lots of pilots in there, in our cockpit. 2 minutes and 7 seconds now to launch. Laser focus, Aaron, as we get close.
Yes, we're seeing a lot of muted enthusiasm at this point. The teams are going to save their enthusiasm for the end of the mission. For now, everyone is focused on their job at hand, monitoring the health of these satellites and the status of the launch vehicle.
Quick word about the launch sequence, Samuel. We actually switched the engine on the main stage about 7 seconds before the boosters. Why is that?
So we have a two-step ignition sequence. We'll start first with the ignition of the main engine, so the Vulcan engine. We'll check during 7 seconds that it's working properly before actually sending the ignition order to the 4 boosters. Of course, once this is done, we will lift off quite quickly. In half a second, there will be the liftoff, and this is because nothing is holding us back.
À tous de DDO, attention pour moins 1 minute. Top, H0 moins 1 minute.
We are 1 minute to launch. Our very best wishes to all the teams and to the Amazon LEO satellites as they get ready to start their journey on board Ariane 64. Good luck, everyone.
Go Ariane 6 and Amazon LEO.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage ESR et décollage. Propulsion nominale, le pilotage est calme. La trajectoire est nominale. Pilotage calme. La trajectoire est calme, les paramètres à bord sont nominaux.
The next 32 satellites.
Propulsion nominale.
The next 32 satellites for
Pilotage
Amazon
calme.
LEO have started their journey on board the first Ariane 6 with 4 boosters. Wow, and that was a
La
beautiful
trajectoire est
launch.
nominale, les
What a
paramètres à bord sont nominaux.
Magnificent liftoff. We can hear Ariane 6 passing by and feel the walls shaking. Wow.
It's taken just around a minute and a half for the sound to get to us.
How powerful that was.
Looking here
Pilotage
at
calme.
the coast of the Amazon rainforest, the coast of French Guiana moving away from us. Those are the onboard cameras. I'm guessing that's the river Kourou, that line on the land that we can see. You can see the clouds moving away behind us. We are burning 5 engines. We ignited them all on the ground, but the boosters are doing all the work for us right now, aren't they?
Most of the work, yeah, indeed, as you said. So remember that the weight of the launcher was 870 tons on ground, and so 90% of the thrust is delivered by the boosters. They'll burn 142 tons in 2 minutes 25 seconds. So we are actually burning 4 tons of propellant each second now.
Séparation des USR.
And we just had confirmation of the boosters separation.
We're seeing the images from the live cameras a few seconds later, and that's perfectly normal. That's for technical reasons. But look, that's how it looks. And they're falling away in perfect formation.
Yeah, and this is to be precisely set and analyzed and checked because, of course, you need the boosters to be jettisoned quite quickly, but not well in a mastered way to avoid any collision, any risk. Wow, nice shot from the onboard cameras.
Our planet Earth. And the next big moment on the left-hand side of your screen, you can see the events coming up, will be the jettisoning of the fairing. That's the nose cone, if you like, of the rocket,
Séparation des
which is
coifes.
protecting our satellites. And we've had confirmation that that's now been separated. We'll see the images, hopefully, on the camera.
So it was long fairing today, first flight for these 2 halves, 20 meters. Whoa, you can see the fairing being jettisoned here.
And you can see how it flexes as it falls. That's all part of the plan.
Yes, indeed, and that's a beautiful movement, but it's due to the fact that it's designed to be as light as possible, but of course, when separated, the loads are pushing it, and it's being deformed due to its stiffness. This creates this movement, what we call a breathing mode. Nice breathing mode here. All designed to sustain that, of course.
Our altitude, 161 kilometers down at the bottom of the screen there. Our distance from the pad and our speed, vitesse is the French word for speed. At the moment, we're traveling at nearly 3 kilometers per second, everybody, per second. And the range operations manager is telling us that everything is going well and everything is going according to plan. Now, I'm rather hoping that Aaron is back with us because we sent him out to go and watch the launch with his own eyes on the terraces. Aaron, what was it like?
Oh, what a magnificent errand. It was like watching a second sunrise. I've never seen flames coming off an Ariane rocket like that. And it was a delight to watch the mighty Ariane 6 rise majestically from its throne before plunging into the vault of the heavens. It was astonishing.
I'm so glad you were able to go and see it, Aaron. It is very powerful, this beast, Ariane 64. So we're burning the main stage. Now, you can just about see the sort of main stage at the bottom of the screen there of the rocket. It's, as Aaron was telling us earlier, it's a great big tank of fuel.
Yes, indeed, it's quite tall. You can't barely, well, you can guess, but from the onboard camera, it seems tall, but it's still 32-meter high diameter 5.4 meter, and we are currently burning the 154 tons of liquid oxygen and hydrogen, as Aaron was discussing earlier. And why are we using these two? This is because the chemistry of these two elements makes that it's one of the most, let's say, fuel-efficient combination that exists to convert that into thrust and hence velocity given to our passengers, the Amazon LEO satellites.
He's telling us that the propulsion is nominal, so everything's going well.
Yeah.
And we separated the boosters using cutting-edge technology called optopyro.
Yes, indeed. These are key technology based on laser pulses sent through optical fibers, and they are used to trigger key pyrotechnic events such as the booster separation, which we've just seen. And next step, and next they will be used for separating the main stage.
So we've just heard there from the range operations manager that we've picked up the signal at the tracking station SNA, he said, which is actually a naval tracking station. So as Aaron explained to us earlier, we're tracking the rocket using telemetry. There are ground stations dotted along our flight path, and the rocket basically is talking to us. It's sending signals as it flies over. The naval tracking station, Aaron, it's in a boat, isn't it?
Yeah, the ground station is on the water. Kind of funny to say that, but yes, it's in the Atlantic, in an area that has a telemetry hole, so we send a boat to that area to track the rocket during its overflight. It has a 5-meter S-band antenna, and it's mounted on a stabilized platform, so if it's wavy, it can have a clear view of the rocket.
Coming up now to the next main event, which will be the extinction of the main engine.
Extinction Vulcain et fin de mission sauvegarde.
And we have confirmation there that the
Séparation
engine is switched
LLPM.
off.
It was just then confirmed that the main stage has been separated as well.
Allumage du moteur Vinci.
And I'm so sorry to interrupt you.
No, and I was to say that the Vinci engine has been fired up, and you can see from the onboard camera the separation of the main stage. Wow, it looks amazing. This again is a very precise step of the flight, and a very key step where you need this stage to be separated gently but quickly enough to ensure the Vinci can fire up.
It looks easy, but actually what's happening up there is unbelievably carefully planned. It's the result of
Tous les paramètres à bord sont nominaux.
very clever brains. And there he's telling us that everything is going normally. So the upper stage is now in charge. We can't actually see it on these shots, but Aaron, I kind of like to think of it as an orbital bus driver, because its job is to deliver our passengers to lots of different bus stops in space.
Again, another handy analogy. Yes, it's the bus driver. Everyone's not getting off at the same stop, but they're all headed in that direction.
Here you can see the Vinci nozzle on the right in orangish color.
The nozzle being the nozzle of the engine.
Yeah.
And the curvature of our planet there in the background, and the very thin blue line, of course, is the atmosphere, our gas mask. So the people who are monitoring all this right now are in what we call the CVI, the quick look telemetry team. The tracking stations are sending the data, relaying it to them. They actually are on a little mountain on the just outside the spaceport. It's called the Montagne des Pères, the Mountain of the Fathers.
And yeah, and they are collecting real-time data, which is sent by Ariane 6 back, of course, through the different stations we are talking. And this data can include the status of the engine, like the turbopump speed, for instance, the tank pressures, or the engine thrust, but also the trajectory, meaning where we are, our velocity, for instance. And they are comparing these live data to what was predicted, what was the plan. And this allows to continuously analyze the behavior and confirm that everything is as planned. Then they are sending a summary of this to the range operation manager, who is then sharing with everybody the recap of the situation.
Indeed, sharing that on their internal comms loop. And the different parts of the Ariane 6 rocket are built in Europe, but they're actually brought here on a boat, which is called Canopy. Aaron, it's really more than just a cargo ship, isn't it? It's quite revolutionary because it has sails.
Yeah, revolutionary. Everything old is new again. We're back to sails for transporting heavy items across the ocean. But the hybrid cargo vessel Canopy brought the Ariane 6 rocket components from France to French Guiana for the LE-01 launch campaign. The ship carried the Ariane 6's core stage, the upper stage, and other critical hardware across the Atlantic to Europe's spaceport in Kourou. Canopy uses a hybrid propulsion system with 4 articulated rigid wing sails that can reduce fuel use and emissions by up to 35%. And the transatlantic voyage, which was kicked off December 5 in Bordeaux, was a major milestone in the Amazon LEO and Arianespace partnership.
That sounds fun. Lots of good wines in Bordeaux.
Could be, yes.
And the ship can also, Canopy can also transport satellites.
Yes, indeed. Remember, we have transported Copernicus Sentinel-2C quite a long time ago, but it was on board Canopy. It was on board Canopy, and we have also requests from other customers to do so, to transport their satellite potentially from mainland Europe to French Guiana. Makes sense to transport them alongside Ariane 6 parts.
So we just heard there from the range operations manager that we've now picked up the signal at the tracking station in Santa Maria. Our flight path takes us northeast from French Guiana. We're flying over Europe, heading towards Europe now. We'll be coming back down over India and then the west of Australia. Then we'll be coming back up again in northeast and heading back to South America. And Santa Maria is now locking onto the rocket's signal. It's a Portuguese island in the Azores, which is an archipelago in the Atlantic. And Aaron, it sounds absolutely beautiful. I had a look at some pictures actually the other day, and I'd quite like to go on holiday.
Yeah, it's very lovely, very warm and sunny in Santa Maria. To give a little geographical lesson, is the southernmost island of the Azores, known for its gentle hills and terraced vineyards and the only white sandy beaches in the archipelago. This tracking station is known as the Montes das Flores, the Hill of Flowers, and it's about 5 kilometers from the historic town of Vila do Porto, some 1,500 kilometers from Lisbon, the capital city of Portugal. And it was first used to track the launch of the European Space Agency's automated transfer vehicle, the Jules Verne, in 2008, the launch I was here for. And Jules Verne was a cargo resupply mission to the International Space Station, bringing critical elements to the station for the astronauts aboard.
I bet they would have been absolutely delighted when they received those things inside the Jules Verne cargo ship. Now, we can see there the teams we were talking about earlier at the Galileo tracking station, the quick look telemetry teams here at the spaceport, analyzing the information coming in from the rocket. And on the bottom right-hand side of your screen, you can see there the upper stage. The white disk is actually the upper stage of the rocket, what's left of the rocket. To the right of it, we can see our satellites, our 32 Amazon LEO satellites attached to the dispenser. And then to the left of the upper stage, you can see there the blue flame is actually the engine, because the upper stage has a very powerful engine. It's called Vinci. Pretty sophisticated piece of kit.
Pretty complex and good piece of engineering here. It's actually a big innovation for Ariane 6 because it gives key mission flexibility, let's say it like this. It's designed to switch on and off, and this up to 4 times. So it allows us to take different spacecraft to a super wide range of orbits. Low Earth orbit, like for today's mission, but also we can target higher orbits, like medium Earth orbit, as we did for Galileo mission last year, or even higher altitude to geostationary orbits at 36,000 kilometers, but also we can use it for exploration or scientific missions. So see a super wide range of targets. And it's the first of Ariane rocket being equipped with this cryogenic engine that can switch on and off. And for this mission, as we said, we'll have 3 burns. Two of these burns will be used to separate precisely the Amazon LEO satellites on their orbit, and the last one.
3 minutes de propulsion.
And last one will be for deorbiting the stage. So the range operation manager saying is that remains 3 minutes during the first boost of Vinci upper stage.
We're 208 kilometers above Earth, and
D'acquisition de la télémesure par la station SNA.
so we've gone out of the range of the naval tracking station. Yep, 205 kilometers high, and our distance from the pad just over 4,000 kilometers. And our speed, ladies and gentlemen, boys and girls, 7 kilometers per second. Now that's what I call fast.
Yeah, super fast. This corresponds to more than 25,000 kilometers an hour. Pretty fast.
Yeah, I think we can safely say that's pretty fast. If you look at the top right of the screen now, our trajectory, the green line is the predicted trajectory, the white cross is the actual position of our rocket, our launcher. We've actually been climbing, and it looks like we've kind of gone over the top of the hill and coming back down the other side.
Yeah, kind of. We are still picking up speed from the Vinci upper stage because the boost is not over, but when we'll switch off the engine, indeed we'll have high velocity, but we'll be down the roller coaster if you want. So we'll use that speed to climb the hill, to go up the roller coaster, and in other words, we'll translate velocity, meaning kinetic energy, into altitude, meaning potential energy.
Now, there's a real need for reliable connectivity. It doesn't matter where you are on Earth, you really want to be connected these days. He's telling us that everything's going normally. And low Earth orbit networks like Amazon LEO can deliver that.
Yeah.
Who will Amazon LEO help to connect, Aaron?
Well, you don't have to go that far to find poor internet. So sometimes it's just down the road. You know, take small businesses in rural France trying to compete in the digital economy, but struggling with unreliable connections, or fishing communities along Europe's northern coasts where reliable weather data and market prices can mean the difference between a successful catch that day or coming home empty-handed. There's mountain rescue teams in the Alps who need real-time coordination during emergencies, but have a hard time connecting. Small bed and breakfasts in remote Scotland, or Tunbridge Wells that can't offer guests the Wi-Fi they expect. Farmers in Spain who want to use precision agriculture tools but can't get the bandwidth to support them. You know, in short, billions of people everywhere who live and work in places where geography and economics have made traditional infrastructure totally unfeasible.
Indeed. And Amazon LEO is built to address all of these use cases and more from a single household.
We had just confirmation of the switch off of the Vinci upper stage engine.
We have indeed.
Yeah, which is good.
And that's really important. It's a very good sign. This is the first major step in reaching the desired orbit. So we are now coasting without the engine. We're in what we call the ballistic phase. That means, what, traveling without propulsion?
Yes, indeed. We are on what we call an intermediate orbit. It's kind of an oval shape orbit, an ellipse. And the closest point of it to the Earth, to the ground, is 150 kilometers high, and the furthest point is 465 kilometers. So we'll use that velocity to climb the orbit to go to the furthest point, and this will take us around 52 minutes to climb that stair, if you want. and
correct, la propulsion est nominale.
So the range operation manager is confirmed that the orbit we have reached at that step is fully okay. It was the targeted one, which is a super good news.
Acquisition de la télémesure par la station Osagel.
And we have acquisition of signal at the tracking station in Osagel, which is in France, Aaron?
Yes, Issus Osagel. It's in the Haute-Garonne, south of Toulouse. The Pink City, which is the home of much of the French aerospace industry, a really significant place.
You can just see it there on the map. It's in southwest France, so we're now heading out over Europe. We're going to take a break while we climb the hill, and we're going to take a break for about 47 minutes now, so we're going to come back to you at about 5:54 GMT, Greenwich Mean Time. That's 2:54 here in Kourou and 12:54 in Washington. So don't go away. See you back here then.
See you there.
Propulsion nominale de l'APU. Fin de visibilité de la station Santa Maria. Propulsion nominale de l'APU, le pilotage est calme. Tous les paramètres à bord sont nominaux. Pilotage calme. Propulsion nominale, le pilotage est calme.